All right, hi folks. Welcome back to Physics with Captain Rod. I'm making this to help you out with number 17 in your Unit 2-2 homework here. Let me kind of look this over. Two blocks connected. Systems released from rust. Mass 1 bigger than mass 2. So, all right. So this system is released from rust, and the first thing I would do, right, is put a datum. This was nice that they put these basically at the same height too. All right, so let's put a datum right there. And when this is released from rest, mass 1 is going to accelerate this way, and mass 2 this way. And the reason is because of this. It says mass 1 bigger than mass 2. So let's call this position 1, and you got to get both of these guys, like these together is the position 1. And then mass 2 is going to accelerate maybe down to here. Let's put a 2 on this. Mass 2 will be up here somewhere. So this is the position 2. And then write out the work energy theorem. All right, so your PE1, again, this is position 1. Both masses are at the datum, and the spring is not stretched. Right? So that'll give you a pretty good idea of how to do PE1. The KE1, I'm sure this thing starts from rust just based on the problem. Actually, it states right there. Hold off on the work term. All right, so PE2. Now the position 2 here, let me use a different deal. Mass 1 is now here, so it's got a gravitational potential energy because it's now down below the datum, some distance here. And that's what they're calling D here. It doesn't matter if you call it D or H or something like that. So your PE2, you're going to have a potential energy for mass 1, and it's negative because it's below the datum. For mass 2, it is above the datum the same distance. So you're going to have a gravitational potential energy for mass 2. In addition to the gravitational potential energy, the spring is also stretched a distance d. So your PE2 should have 3 terms. One of them should be negative from that animal and 2 positives from this. And then at maximum displacement, your kinetic energies are 0. Now, as far as work term here, so the gravitational forces acting on these masses, they're taken into account with the potential energies, as is the spring. The only thing to wonder about is maybe the rope. The rope pulls up on this animal doing positive work, but here the force applied by the rope is up. The thing is moving down. That's going to be a negative work term. Long story short, there's no net work done by the tension. So get all those things written out, and you should be able to solve that for D. So that should be probably enough for 17 there. I'm going to call that one